Hello and welcome to 2D. This is going to talk about the lunar cycle, and what I basically have here are the pictures of the 8 phases of the moon, if we include the new moon and we include the full moon. And then waxing going this direction, waxing means getting larger, and if you notice the right side of each of these moons is actually getting larger. And then we have the waning side on this one, and you can see the right side is getting larger but darker, and the lit side is getting smaller. Waning actually means to get smaller. Waxing means to get bigger. Easiest way for you to maybe remember that is if you in the winter and you toboggan or ski or you do something that you wax the skis or you wax the toboggan or the sled rungs. Waxing actually adds wax to it and make the thing larger. And bright on the right, waxing. Bright on the left, not. This is actually lumination, which is showing you the moon going through the right side getting larger and the dark side getting, or the left side getting smaller. This is actually from 2005. It also shows you that the moon gets larger and smaller. And it also shows you that it actually seems to tilt a little bit. And this is from the actual direction of where you are on the Earth. If you're on this side of the Earth, you get to see a little bit more of this side of the moon. And as you rotate around, you get to see a little bit more of this side, and that's why you're getting this image. The moon does get closer and farther. It is an elliptical orbit, and that's what that is showing at that point. Next slide, this is going to be a picture I'm going to have you draw in class. So I'm just going to go, there's the sun coming into this direction, and I guess I could actually draw something here. What you'd basically do is from space out here you'd actually get sun illuminated side on this side, the dark side would be on this side, and that would be true for all of these. And I'll draw what it looks like from Earth in class. Basically from outside, and hopefully I'll give you a different diagram that actually has an inside and outside. But viewed from space, the dark side's always going to be away from the sun. So moon doesn't really go through these, and I'm not staying within the line very well because I'm trying to go through, and the mouse actually is not the best drawing tool. But from space, the moon does not go through phases, but viewed from the Earth, if you take a look at, can I pick a different color here? If you take a look at what side the Earth sees, the entire side that the Earth sees is dark. The entire side of most of the moon is dark, a little bit on this side, and actually we should go in this direction because it moves in a counterclockwise direction. And if we draw a line in between the orbits, straight line in between the orbits, you actually see where this would be totally lit, this is mostly lit, this is half lit, this is a little bit lit. This is the waxing quarter. If you take a look at it, it's going to be on the right hand side. This is the waxing crescent, waxing quarter, waxing gibbous, full moon, and then this one is the waning, getting larger on the right, smaller on the left. This is the waning gibbous, the waning half, and the waning crescent, and those are the phases of the moon. And there's the image showing you what I drew, and there are the 8 moons, and we'll talk about this thing in class too. But the 12 p.m. is there, the 12 a.m. is there, and as the Earth actually rotates, the first moon we would see is going to be this moon, moon 3, which is the waxing half moon, or the first quarter, and we'd actually see it set at 12 midnight. 3 p.m. to 3 a.m. as we go around, the first moon we would see is this one, and then it would set at 3 a.m. 6 a.m. first moon we would actually see would be the 6 p.m. the first moon we would see is the full moon, and it would set at 6 a.m. and at 9 a.m. first moon we would see would be this gibbous, and it would set. And then if you fill in the rest of them, so like at 3 a.m. first moon you would see would be this one, 6 a.m. first moon you'd see with that one, 9 a.m. first moon you would see would be this one, 12 p.m. noon would be that one, and then just keeps going around, and you would actually see it set 12 hours later, or rise and 12 hours later set. Same thing all the way around. Smooth draw. Okay, another familiar cycle. Um, this is this is still the moon phases. And if you take a look at the noon moon, we're actually going to see this is a new moon. It rises at 6 and sets at 6 p.m. But at 12 noon, it would be right in the middle of the sky, just like in 12 midnight, this full moon would be in the sky. Same sort of thing. And it does have a synodic period of 29.5 days. And what that basically means from new moon to new moon, 29.5 days, or first quarter, excuse me, waxing crescent to waxing crescent, first quarter to first quarter, waxing gibbous to waxing gibbous, full moon to full moon, 29.5 days. And that's going to actually differ in terms of the moon going around the Earth, because the moon goes around the Earth every 27.3 days, and we'll talk about that later on. And you see that picture right there? That's telling you I would like you to draw this picture. Sun comes in, sun always points to the new moon, and it illuminates the side facing the sun. It does not illuminate the side facing away, and it all depends on what side we see and how much of it's lit up by the sun and how much of it's not. And those are what are the apparent changes of the moon, going from new moon all the way through around back to the new moon 8 minutes later. One common misconception is that the moon is only visible at night. There is the Eiffel Tower in Paris, and you can see we actually have a moon sitting up in the sky, and this is a little bit more than a half or a quarter moon. This is approaching the gibbous. The right side is lit up, so this is a waxing gibbous. You can sort of make out the man in the moon in this picture as well. Synodic moon, again, takes 29.5 days. The sidereal moon takes 27.3 days, and the way it works is if you take a look at the new moon, sun illuminated side of the moon, the dark side's facing the Earth. This is a new moon, and as it goes around, taking 27.3 days to go around, it would be a new moon again, except that the Earth actually moves over to this direction in about a month. And what happens is the new moon isn't there anymore. These two lines are parallel. The moon actually has to move an additional almost 2 days to catch up to the sun because the Earth has moved around. And the next time it'll happen is there, and the new moon would want to go in this direction, but it's got to go an extra 2 days to move to that location. And this is something, again, I'd like you to draw. There are two types of eclipse, also caused by these moons. There's what's called the solar eclipse. This is when the moon gets directly between the sun and the Earth, and what happens is the shadow of the moon hits the Earth, and if you notice, it's a very small shadow. In fact, the very inside of this thing, which may be 30 miles wide, is actually the only part that sees a total eclipse. Then there's a partial eclipse, and folks out here don't get to see a thing. It's just a sunny day. The lunar eclipse is actually seen by a whole lot of people. And what this is, we got the sun in the background, we have the Earth, and you see a little bit of red light coming through. And this is the reason why a lunar eclipse actually has that blood moon kind of color. And it's not because that's the color of the moon, it's because the only light that actually hits it is the stuff that goes through our atmosphere. And if you've ever seen the sun low in the sky, it actually gets that orangish reddish appearance, and that's because the blue light is gone and the only light that's getting through is the red. Here's an animation of a solar eclipse, and it takes a while for the animation to actually load. You see we have a sun, we have an Earth, and we have a moon. There's the moon shadow, and what it does, it actually touches the Earth and causes this itty bitty teeny tiny itsy bitsy line, and those are the only people that get to see the total eclipse. And a little bit out farther, a little bit more, they see partial eclipse. Here's another diagram I'd like you to draw, and the way this is drawn is we have the Earth, we have the moon, and we have the sun, and this is definitely not to scale. This is 400 times smaller than that, which that is not. It's also 400 times closer than this one, and because of that they have almost the same appearance in the sky. But the way you draw this is you draw a sun, and then you draw a line from the top of the sun to the top of the moon, touching the Earth, and you draw a line from the bottom of the sun to the bottom of the moon, and then the top of the sun to the bottom of the moon, and the bottom of the sun to the top of the moon. And what that does is it actually shows you where the sun light is not visible. There's no place on this side of the moon that actually sees that sun, and because of that, there's no place inside this itty bitty teeny tiny area right here that also sees the sun. And if you go out here, you see a little bit of the sun. Go a little farther, you see more of the sun, and go out a little farther and you see more of the sun, and it keeps going farther and farther out until you get out of this penumbra, and then you can see basically the top of the sun, the bottom of the sun, the entire sun. Here's a picture of the moon actually moving in front of the sun. You can see there are sunspots, and these sunspots are probably 4 to 5, maybe 10 times longer or wider than what the Earth would look like if it was on there. These are more like Earth-size sunspots, so this is a very large star, at least compared to our Earth. And then every once in a while, sometimes we get that smallest moon, or we get the biggest sun because it actually moves, like that perihelion and aphelion diagram I had you guys look at a couple videos ago, or maybe last video. This is actually being made on 9/11. So I made the other ones earlier than that. But basically what happens when we get the small moon, it may not cover the sun, or we get the big sun and we get a small moon, it may not cover the sun. This is called an annular eclipse. So we can have a total eclipse, a partial eclipse, or what's called an annular eclipse, where a little bit of the sun is showing through. And again, that's where we get a supermoon, where the moon is actually closest and it's full, or we get what's called a micromoon when it's farthest and full, and it's 14% bigger here, and it's also 30% brighter because you like double the size. Here's an animation of a total lunar eclipse, and we're going to have the sun here, and we're going to have the Earth there, and we're going to have the moon here, and the moon's going to move into the Earth's shadow. Moon is smaller, the Earth's shadow is larger, so this lasts a lot longer, and there's the blood moon. I'd like you to draw this diagram too, and the same sort of thing. You draw the Earth, and you draw a line from the top of the sun to the top of the Earth, top of the sun to the bottom of the Earth, bottom of the sun to the top of the Earth, and the bottom of the sun to the bottom of the Earth. And you see that the shadow of the Earth is a lot larger, the moon is a lot smaller, so it spends more time. And that also means that everybody that's on this side of the Earth, for the entire period of it moving through the penumbra, which is completely round because it's a round Earth, into the completely round umbra because of the round Earth and the round sun, but it actually moves into it, and it takes sometimes hours for this whole process. So as the Earth is rotating around, more than half the Earth gets to see a lunar eclipse, and remember that very small portion of the Earth that actually gets to see a solar eclipse. And this is why people think lunar eclipses happen more often. They happen about the same amount of time. The umbra is the total eclipse part, penumbra is the partial eclipse part. Umbrella, you can think about that. You don't want the umbrella to block out most of or some of the rain. You want it to block out all the rain. This is the totally blocked out part of the shadow, and this would be a partially blocked out part of the shadow. Here's the moon actually moving through from 8:45 to 9:40. It starts actually getting a partial eclipse, and then 10, and then 11. So this whole process looks like it's about 4 hours long, and the Earth would rotate, 50, 60 degrees. So the entire half of the Earth plus an extra 60 degrees gets to see this eclipse. It's pretty amazing. And here is the blood moon, and again that's caused because the Earth actually has this round, actually be in this picture, has this round shape, and the only light that actually gets through from the sun is this reddish color, and it makes this moon look blood red. Okay, during a new and full moon, we don't always get a lunar eclipse, and this is because if you take a look, the moon's axis of revolution is actually tilted 5 degrees to the ecliptic, the sun's path, and sometimes the moon is going to be too low and it passes underneath the Earth, or sometimes the Earth's shadow is too low and passes underneath the moon, so we don't get a solar eclipse and we don't get a lunar eclipse. And the same thing here, it's a little bit too low or a little bit too high, only when it reaches what's called the node, where the line of the moon's orbit actually intersects the line of the sun's orbit. And if the moon is right there, which is not very often, we get a solar eclipse. And again, remember, not very much of the Earth gets the effect. And then if the moon moves into it, we get a lunar eclipse, and we get them only in these locations of the orbit around the Earth. So it can only happen if we get a new moon here or a full moon here. If we get a full moon when the Earth is right here, it's not going to block it out. Or if we get a new moon when the moon is right there, it's not going to block it out. And here's another picture I'd like you to draw. And again, that's that 5% tilt in respect to the Earth-Sun ecliptic plane. Three types of lunar eclipses. We can actually have the moon move right smack through the middle, and we call that a total eclipse because it reaches the umbra. We can just touch the umbra, and we call that a partial eclipse, or the moon can move through the penumbra, which we call a penumbral eclipse. And here's a moon that actually looks like it's going through, it still gets that blood red color, but the bottom of it looks a little bit lit up. So it's just traveling a little bit too low to be a total eclipse. Here's a penumbral eclipse. We get a little bit of a blocking out a little bit of a darker area on the moon, but chances are you'll think it's a cloud. Really tough to see. Here is a partial eclipse where we actually get it moving through the umbra of the Earth, and we get part of the moon, and sometimes that's all the eclipse will get. And then there is a total eclipse, again getting that nice red color, because looking at, if you were standing on the moon looking at the Earth, it would look like this, and there's North America, and there is us. And if you take a look around the Earth, all we get, and this is how thin our atmosphere is in relation to this entire side of the Earth. You can see we have some section of the sun showing. This is the corona, and you can see that red light, yellow light, orange light. That's the only light that actually travels back to the moon and then bounces back to the Earth, so it gets that nice true reddish color. Here's an eclipse from 2016 to 2017. You can see in August we had a lunar eclipse, and it was visible by almost the entire Earth. We had a cloudy day back then. I didn't get a chance to see it, but we would not have seen much of it because it actually is just coming out at that point. There's a solar eclipse that's going to go through this part of Africa on September 1st. That's already happened. September 16th and 17th, which is this next weekend, except we're not going to be able to see it. But you can see most of the entire Earth gets to see it from the pole to pole, and from the very tip of South America all the way over to this side of Russia, almost into the Aleutian Islands. I guess some of them will get to see it. We'll have a lunar penumbral, so we'll get a little bit of it blocked out. February 2017. February 26 we'll get an annular eclipse, but again it's going to be too low for us, and you can see that very small section compared to very large sections for lunar eclipses. And then on August 21st 2017, and I've been telling kids since our school opened up in 2000, I probably told Potomac kids before that, this is going to be the next eclipse that's going to get really close to us. And if you want to see a video on that, you can actually click this and see a video that I made. Not even sure when I made it, 5 years ago, something like that, talking about this eclipse. And I'm hoping I'm actually right here in the middle. I'm going to try to be in St. Louis for this eclipse. I was thinking Wyoming, but the Wyoming eclipse won't last as long. The largest eclipse time, I think it's 2.5 minutes, is going to be the section here in St. Louis. Lunar eclipse occur after with the moon shadow reaches the Earth, and again, really small. Unlike lunar eclipse, the solar eclipse happens at very specific parts of the Earth, indicated by the arrow, and it's actually that little section right there. So it's not a very large section of the Earth actually gets to see a solar eclipse, and that section right there actually gets to see a larger solar eclipse than anybody this way. Very short solar eclipse at that point, very short at this end, long in the middle. Totality may last as long as 7 minutes and 31 seconds, but most of them are going to be much shorter. And like I said, that one in August 2017 is about 2.5 minutes of totality, so it's not going to be anywhere close to this 7.5 minutes. If you're located in the umbra, you're going to see a total eclipse. There's the moon moving in front of the sun. Actually, that's the Earth moving in front of the sun. And nope, that's the moon moving in front of the sun. It's an artist's depiction of it. You can see the corona, and you'd actually get a nice dark view. Here's the moon actually moving across it's actually moving in this direction across the sun as it moves in this direction, and it doesn't completely block it out. For an annular eclipse, those just outside this region and the penumbra is going to see a partial eclipse. And sometimes the eclipse occurs when the moon is too far away, apogee, or the sun is too close, perihelion. And what happens, we get a bigger than normal sun, or we get a smaller than normal moon, and we get what's called an annular eclipse at that point. So what do we know? We know that the North Star Polaris is or is not the brightest star in the sky. No, it's a medium brightness, about the 20th brightest star in our sky. Do astronomers regard constellations as familiar patterns of stars in the sky? Sometimes, but usually it's the area, the region in which that constellation takes up, and it's sort of like a state. What causes seasons? Has nothing to do with the distance of the Earth and the Moon and the Sun. It has everything to do with the tilt of the Earth and the apparent change in position and length of the day in respect to other days. When is the Earth closest to the Sun? January 3rd, perihelion, each year. Could be the 2nd or the 5th, too. How many zodiac constellations are there? There are really 12, but we're going to say there are 13, but there really are 12 zodiac constellations. Remember that Herder doesn't quite make it in there. Does the moon have a dark side that we never see from the Earth? Yes, it does, but it's not always dark. When it's new moon on our side, it's lit up. So half the moon's always dark, but the side we see, full moon, the side we don't see is going to be the dark side, and that's the only time it is dark, when it's a full moon for us. Is the moon ever visible during the daytime? About half the time, and about half the year. And I think that is it. So thanks for stopping by. 22 minutes. Adios.